Welcome to my presentation, Professor and all of my friends. Today, I would like to present my presentation that's about implementation deep learning on household hazardous waste identification under guidance Professor Chin Cheng Chu. And these are our group member, myself, Lina Indawati, and my friend Hendy Prastio. This presentation contains of introduction, and this will be presented by Handy, and method and process data will be explained by me, and then TL model will be explained by me and Handy, and then a conclusion will be explained by me.
Hello everyone, I'm Handi. Let's go to the background. Why we need to detection the hazardous waste? Because the first one is the hazardous waste that dangerous and risk to human health. And the second one, hazardous, it can generate household. So we can classification hazardous waste and take further action to prevent the danger posed by hazardous waste. Objective. So we first collect the data object from your set. After that, deep learning include computer, program, code can be generate and process the data, and then we can know which one the higher dose with and which one the domestic non higher dose with. Yes.
Here, our methods is talk about tool and materials. We use phone camera and then computer and then examples such as maps, and then this is sanitary pads, and this is the bottles of toilet disinfectant, and this is diapers. And then we use the program PyTorch and YOLO V5, Google Colabs, because we run our model on Google Colabs, and then TensorFlow and also Python. We use some code from these code programs and some library from this program. And make sense is about labeling. We use make sense, create labeling on our training and validation data. And before we train our model, we have to pre-train our model. Pre-trained models contains such as a preparation of data set. First, we have to create labeling of the input training data. We use AI, and this is an example of a labeling, such as we create a labeling on Python. We mix a box and then we put the label, the name of the label, and then we save on ULV file format. And then we create path code. Then we create path code to connect our input training data and validation data to our models. Here the codes, this one the code, this one the place that put our input training and validation data. And then this is the class. We can create one class, two class, or many classes. It's depend on us. And this is the name of the class we put here. It's depend on us. We can change this code here. And then we have to set up our model. First, we have to clone repo, install dependency, and check PyTorch and GPU. And then we clone UV5 from GitHub. This is the link. And then we install GR requirement txt and torch utils and display using this code. And then we have to put exclamation mark here because we run our model on Google Collapse. And this the path of training. First, we have to upload the input training and validation data, the folder that we have create path code with that we create before, and then we annotate, and then we train, and then deploy. And then we have to create the code for TensorBoard and also weight and bias. And we have to install T1DB. And then we have to create the code of the training. We use a Python train.py with the size of a pixel 640 and the batch 16 and the epoch 550. And this is our name of the path, so the model can read the code. And then this is the way YOLOv5s.pt. And then we come to the model training and test. This is validation. We can see here the process of the training and validation or test. The process is very fast. We just need 7 minutes. This depends on our internet connection. If our internet connection is very fast, it will be very fast. This is the GPU. And then this is the epochs. Actually, 500 and then 50. And then this is the image size, and this is the accuracy. Accuracy of the model is medium. It's not too high, but it's not too low. Now, Handi will explain about this.
Now we heading the label trends. Actually, the graphic that we get from the training dataset is collect of the data from object labeling with .txt format. I will explain about this labeling .txt format. This is two. Two is meaning a number of object. How many classification that we need? And this 0.14 is image width from boundary center the box, and this 0.5 and so on is image height, and 0.227 is all image weight, and after that 0.9 is image height from below. This is precision and recall. We can see precision is measure of result relevancy or quality result, and the recall is measure of how many truly relevant results are returned or quantity result. So we can see the result from the picture that we get, that the result is standard medium, not good and not bad. After that, we have a result of loss precision and recall. We can see in the picture that the result of loss precision and recall is good. Training loss is 0.02 until 0.12, and validation loss is 0.02 until 0.06. That we get a result of image train label. Result of image train label, the program generate the object with the name tag is 0 first. This is 0 first. And after that, we can get in the validation image process, the program gives the object with the truly name tag that we read in the code.yml. So this is a truly name tag from the object detection. After that, Lina will explanation.
Okay, we come to the running of the models, and then we have to create a code for running the models. And here we use Python to tag .py source, and this is 0 for webcam. Want to use a webcam or real time, we can change this one a 1 or 2. If your webcam is 1, we have to write 1. If your webcam or camera more than 1, you can change this more than 1. We create to make our model can detect image, and then this video and path and stuff. And then we can see here the process of the running of the model. Okay, this is the process of the running. So the model can detect the video. First, we have to put the weight from the training. This is the code. After we create this one, we get code this one. We have to create put the code here. We get this code weight from the training our model, and this is the image size on pixels 640, and this is the configuration value, and this one I put 0.25, and this is the name of the video that I after running process, and then we can get the result of the model. So we can find the result of our running model is here in this folder runs, and I run 9 times. So this model will create a folder at 9 exp9, so we will find the video 4 on exp9. This is the result for video 4. So actually the result of the precision is not too high or it's not too low. It's around 0.48 until 0.6 is medium. It's not too high or it's not too low. Now we come to the conclusion, and this model still have a lot of limitation and need some improvement. We need higher quality input data, because higher quality input data is needed to get a better accuracy and precision result. And I think Google Pro or Pro Plus version is more recommended than a free version, because free version has a lot of limitations such as setting on GPU and compatible code problem. And the last, set up more epoch to improve the accuracy results. This is our reference. Thank you for watching our presentation.